All right, let's dive right in. We're about to journey to the most extreme, most bizarre places in the entire universe. We're talking about places so dense, so powerful, that the laws of physics, the very fabric of time and space, completely break down. Yep, we're talking about the universe's ultimate mystery, black holes.
So, our investigation really kicks off with a question that haunted physicists for centuries. Honestly, it sounds like something straight out of science fiction. What in the world happens when a star dies and leaves behind an invisible monster?
You know, what's so wild about the story of the black hole is that it didn't start with someone looking through a telescope. Nope. It started as a ghost, a phantom, lurking in the math of our most important theories about the cosmos.
And just think about how long this took. For almost 200 years, this whole black hole thing was just a weird theoretical idea. It started way back in 1783 with this simple concept of a dark star, so massive that even light couldn't escape it. And from there, the idea just slowly took shape in the minds of the greatest physicists in history. But the real game changer? That was Albert Einstein. He didn't just tweak our understanding of gravity. He completely ripped it up and started over. See, for Newton, gravity was this mysterious force pulling things together. But for Einstein, gravity wasn't a force at all. It was the shape of the universe itself.
Einstein gave us this incredible new way of seeing things. He imagined the universe as this huge, flexible sheet called spacetime. Think of a trampoline. You put a bowling ball in the middle, and it creates a dip, a curve. That's what massive objects do to spacetime. And his math predicted something absolutely terrifying, that if you crammed enough mass into a tiny enough point, it wouldn't just curve spacetime, it would puncture it, creating a hole with infinite depth.
Okay, so the theory was there, the math was on the page. But how in the world do you go out and find a monster that is, by its very definition, completely invisible? Well, astronomers had to become cosmic detectives, searching for clues left at the scene of the crime.
And the first huge piece of evidence didn't come from seeing something new. It came from watching the wild, frantic dance of stars right at the heart of our very own galaxy, the Milky Way.
So here's how the case unfolded. Astronomers are tracking these stars, and they see them whipping around a central point at just insane speeds. But when they point their telescopes at that exact spot, there's nothing there. It's empty. But based on how fast those stars are moving, whatever is there has to have the mass of 4 million suns. That's when they knew they'd found their prime suspect, an invisible object we now call Sagittarius A star.
The next clue was, believe it or not, even more dramatic. It wasn't something we saw, but something we sort of heard. A violent scream of high-energy light that basically gave away the monster's feeding habits.
See, when a black hole eats, it is a messy, messy eater. Any gas and dust that gets too close gets pulled into this swirling vortex called an accretion disk. And as that stuff spirals closer and closer, friction and gravity heat it up to millions of degrees until it lets out this unbelievably bright scream of X-rays. It's like the black hole is a messy eater, and the accretion disk is the glowing food all over its face, giving away its location.
So, for centuries, we had theories, we had clues, we had all this circumstantial evidence. And then, in 2019, humanity finally saw the unseeable. The case was officially closed.
This is it. I mean, just look at that. That's not an artist's impression. It's a real photograph. The Event Horizon Telescope, which is basically an Earth-sized network of telescopes all working together, captured this incredible image. It's the shadow of a supermassive black hole in a galaxy called M87, a true beast, weighing in at 6.5 billion times the mass of our sun. Theory had finally become reality.
So we know they're real. We've literally seen one. Which, of course, brings us to the next terrifying question. What would actually happen if you fell into one?
Well, it is absolutely a one-way trip. And it's a weird one. First, as you get close, time itself starts to warp. For you, time slows down compared to the rest of the universe. Then you cross the event horizon, the point of no return. After that, there's no escape. Then comes the less pleasant part, spaghettification. The gravity at your feet would be so much stronger than at your head that you'd be stretched into a long, thin noodle of atoms. Your journey ends at the singularity, a point of infinite density where our understanding of physics just stops.
Now, it's really important to get this. The event horizon isn't a physical surface. You wouldn't crash into it. It's simply a point in space. It's the precise line where gravity becomes so ridiculously strong that to escape, you'd have to travel faster than the speed of light. And since nothing can do that, it's the ultimate point of no return.
You know, black holes aren't just cosmic curiosities. They are fundamental players in the universe. They're both architects and tyrants, coming in all sorts of sizes, from your neighborhood bullies to the absolute godfathers that run entire galaxies.
So we mostly find two main types. You've got your stellar black holes, which are the dead cores of massive stars. They're scattered all over the place. But then you have the supermassive black holes. These are the monsters that lurk at the center of pretty much every big galaxy, including ours. And here's the crazy part. We're still not totally sure where these behemoths came from.
Take Sagittarius A star, the one at the heart of our Milky Way. It weighs about 4 million times as much as our Sun. I mean, by any normal standard, that is just enormous.
But then you meet a true titan, something like TON 618. This thing is so mind-bogglingly huge. We're talking 66 billion suns that our entire solar system could fit inside its event horizon thousands of times over. That's not just a monster. It's a monster on a scale that's almost impossible to comprehend.
And this is where our journey takes a turn from the observable into the truly mind-bending world of theoretical physics. It's where we ask the biggest question of all. What if black holes aren't just the end of things? What if they're also the beginning?
Okay, to get this next part, you have to know about one of the most sacred bedrock rules in all of physics. Information can never, ever be truly lost. So if you burn a book, in theory, you could piece that book back together from every single particle of ash and smoke. The information about the book is still out there in the universe.
And right here is the paradox. Black holes seem to be the ultimate information shredders. They take a star with all its complex information and crush it down to a single point, seemingly wiping its history from the universe. And this clash between Einstein's gravity and quantum physics is one of the biggest unsolved problems in science today.
But what if that information isn't destroyed? What if it gets repurposed? One wild but very compelling theory points out that the math that describes the singularity at the heart of a black hole looks shockingly similar to the math that describes the Big Bang. This has led some physicists to suggest that maybe every single black hole is a seed for a new baby universe. And that leads us to the final, absolutely mind-bending possibility. If that theory is right, it means our own Big Bang might have just been the result of a black hole forming in some other, older parent universe. It means we could be living inside a black hole right now. And it means that every black hole we see in our sky isn't just an endpoint, but a potential beginning, a doorway to another reality. What we call our universe might just be one tiny outcome in a cosmic cycle we're only just beginning to imagine.